Howdy. Let's talk about Birkeland Currents. That's our Earth. And this is the Sun. The Birkeland Currents. Now I have to draw it again. Yeah, that's the second attempt to make this video already. That's the Sun. And that's the Birkeland Current, which connects us. Of course, it's in the middle. It's at the poles. It should be at the poles. As we zoom in a little bit, we notice that there are several of those spinning features here. And they might be also called diachotron instabilities. And of course, they are not stationary, they move all the time. And we can see this movement of them here. I will put a link below to this. You can check it out by yourself. I was watching this just before, and I've noticed that somehow it starts to speed up in the end. So there's just a somewhat 10-second clip available. You cannot adjust or anything. But somehow it seems it starts to gain in speed and spinning around like that at the end of the sequence. It's a little bit hard to see, I know. As if it would get all of a sudden a push and it starts to spin much faster around. Now I've been showing you the solar cycle prediction with this almost vertical line. That's the prediction, and that's the time until sun cycle peak. So, and if this is almost vertical, how many solar flares we still get? If this is going up and it just increases the sun activity, sunspots, like all of these CMEs flaring. And since there's about 2 years or something until we are at the peak of the sun cycle, it might double peak. But there is still a whole big journey to go upwards in solar activity. And so I think the increased solar activity is also responsible for the shorter days on Earth. And if this is really something that it just doesn't look like that, it starts to get speed. See that? In the end, it just starts to whoop, gets around. I think this would be something very important to notice. And I still wanted to show you two things about Birkeland Currents. The first one is from ESA, European Space Agency. Birkeland Currents 2017. ESA swarm has been used to improve our understanding of vast sheets of electric current in the upper atmosphere. Birkeland Currents carry up to 1 terawatt of electric power to the upper atmosphere. About 30 times the energy consumed in New York during a heat wave. They are also responsible for aurora arcs, the familiar, slow-moving green curtains of light that can extend from horizon to horizon. Like this one did on the 8th of August. The surprising geomagnetic activity, which also caught NASA by surprise. And I haven't seen such a display of auroras here ever. Yeah, of course, I lived just 9 years or something here, but still, haven't ever seen. Neither in any other place. So this was very fascinating. But let's go back to the article. Recent observations by SWARM have revealed that they are associated with large electrical fields and occur where upwards and downwards Birkeland currents connect through the ionosphere. Scientists have also discovered that these strong electric fields drive supersonic plasma jets. Yes, they go through Earth, through the core. Yes, how else? Not just around, they go through it. But let's have a quick word still about Birkeland Currents from Donald E. Scott, Thunderbolts project. Have a listen quickly to this. He knows about Birkeland Currents.
As we get farther away from the central axis of the flow, the pitch angles of those spiral pathways gradually increase. And this produces an intertwined internal structure that has several self-maintaining properties. Nothing leaks out of the resulting flow, for one. And this immediately explains why BCs can maintain their integrity over distances of millions of miles, and now we think perhaps even millions of light years. One of the unique properties of any Birkeland current can be seen by viewing a cross-section of the structure of the model. This clearly shows counter-rotation. There are clockwise flows at certain radial distances out from the center axis, and counterclockwise rotation at other distances. We have known for many years that Birkeland currents power the auroral displays we see in the night sky, but were counter-rotating plasmas observed? It was quickly discovered that, yes, counter-rotation is often seen in Earth's auroras. And it's also seen in NASA videos of the poles of several of the planets, especially Saturn and Jupiter. This is evidence that what we're saying is correct, that counter-rotation does exist in these Birkeland currents.
So I will put a link below to this video as well. I recommend you, if you haven't watched it, do it. Or watch it twice. Watch it today and tomorrow again. But anyway, I think it's interesting to watch the Birkeland currents, because all the winds on Earth are ionic winds. Weather is entirely an electrical phenomenon. And we are within the same electromagnetic environment, playing, so to say, our own part. But yes, I think I'll leave it here. Except I just spotted one thing. A few days ago I told you about this, which makes a U-turn over the ocean, which was a little bit strange. Now it seems this is straight up connected to us. That's why we got the heat wave here once again. It takes a spin around and comes back. So, Kursk magnetic anomaly is somewhere here. And that's a high pressure system. And this might take its place again once over the Kursk magnetic anomaly. There is obviously some very strong telluric current boundary here in front of Norway, which seems to influence the weather as well very much. It is in a way shielding Europe. But anyway, I think I'll leave it here, and this could be, once again, endless topics. We are all in this together. Rather wild winds over Europe. Yeah, look at that. And we are going into fall. And fall is the season usually where we get the storms in Europe. And I just now talk about Europe in general. And we already have and had many extreme weather events in many places in Europe. And they will just increase in the coming weeks and months. So be aware of that. Take your time and check out the weather in whatever way you do it. If you have something which we are growing outside, would it be worth to just take them in and not wait until they get destroyed by hail or whatever? Or leave them out and try to protect them from hail at least. And remember the wind, so whatever things you use, they have to be made that they are stable, locked in place. Otherwise, just take the fruits and eat them before they get destroyed. If you are lucky enough to have your own food growing. If you're not, you probably should start now. In whatever way, use the resources you have. You will find plenty of knowledge how to grow food at home in small spaces and all this kind of stuff. Maybe you need to get some equipment, but do it now as long as it is still available. So, I will leave it here. Wild weather over Europe. Surface conductivity anomaly. With the channeling here. Here we have plus, here we have minus. So it's making a channel. But anyway, thanks. Bye.